DSA stands for data structures and algorithms. Data structures are ways of organizing and storing data in a computer, like containers in programming. Algorithms are step-by-step procedures or formulas for solving problems or performing computations, like instructions to manipulate the data stored in those structures. In essence, DSA is a fundamental concept in computer science that combines these two elements to help you organize and manage data efficiently. This involves choosing the right data structure for the specific type of data you're working with and the operations you need to perform. Solve problems efficiently. Algorithms provide the logic and instructions for processing data stored in data structures, ensuring tasks are completed quickly and with minimal resource usage. Why is DSA important? Efficiency. Choosing the right data structures and algorithms allows you to write code that runs faster and uses less memory, time and space complexity. Problem solving. DSA equips you with a systematic approach to tackle complex problems by breaking them down into smaller parts and using appropriate data structures and algorithms to solve them. Scalability. Designing efficient solutions using DSA helps ensure that software applications can handle large amounts of data and increasing user loads. Foundation for advanced topics. Concepts in machine learning, AI, databases, and system design rely heavily on a strong understanding of DSA. Think of it like this. Imagine you're building a library catalog system. Data structure. You might use a tree data structure to organize books hierarchically by genre, author, and title, allowing for efficient searching. Algorithm. When a user searches for a specific book, a searching algorithm, like binary search, can be used to quickly locate the book within the tree structure. Common examples of data structures. Arrays. A collection of elements stored at contiguous memory locations. Linked lists. A sequence of nodes where each node points to the next. Stacks a last in, first out. LIFO data structure, like a pile of plates. Queues. A first in, a first out, FIFO data structure, like a waiting line. Trees. Hierarchical structures with parent-child relationships, useful for representing organizational structures or file systems. Graphs. Collections of interconnected nodes, vertices, and edges used to model networks or relationships. Common examples of algorithms. Sorting algorithms are e.g., quicksort, merge sort, used to arrange data in a specific order. Searching algorithms, e.g., binary search, linear search, used to find specific elements within data structures. Graph algorithms, e.g., Dijkstra's algorithm for finding the shortest path, used to solve problems involving graphs. In summary, DSA is a fundamental skill for programmers and computer scientists, enabling the creation of efficient, scalable, and robust software solutions by effectively organizing and processing data.